Welcome to the final notebook of the workshop. We've already gone through a lot of different material, and I'd be curious to hear how long it takes to really work through everything. But this notebook contains, I feel like, the final missing piece, which is a way to create very custom, bespoke UI elements and visualizations. So let's say you want to wrap some existing JavaScript libraries that you found for creating, process tree visualizations or very rich user interfaces, like just using WebGL or something like that. Like, this is the way to do it. Something that you can't achieve by stacking together the UI components that Marimo gives you out of the box. The way to implement custom functionality like this is through the anywidget library, which is a way of building custom interactive widgets, and it has support for many sort of hosts, Jupyter, certain web application frameworks, and also Marimo. It's really the framework that Marimo uses as the default extension library, basically. So there's a lot of things we could go into when it comes to anywidgets. We will just touch on the functionality and sort of give an explanation that gives you enough information to implement the widgets that you need. So at a very high level, what the anywidget library needs to provide for us is a way to synchronize the Python state and the browser UI state. So to make this more concrete, let's say we want to re-implement the text widget that Marimo gives you. So on the front end side, you have a HTML input. And then as you type characters into that input bar, you need to synchronize that state. So what you have written so far, the contents of the input field, back to Python. So, cells that depends on that widget state, the input field, will automatically be reevaluated. So that is the core problem here, the synchronization back and forth. As users, the way we need to think about this is, in Python, we are subclassing the anywidget class, and then we define the Python state using this trait list. Like, for example, here we have an integer that we want to synchronize back and forth between the front end. And this could be a text variable for the text input field. And then what anywidget library defines is this ES module like this, which has a initialization function and a render function. So it's instructive here to look at the state flow. How it works is that if you update one of these state variables, these traits, then anywidget somehow, that's the library, conveys that to the front end, and the front end needs to reflect that, so it updates. And to go the other way, what happens is that you, for this object here, let's just close this model, you call model set and model save changes, and then the updated value will be reflected here in this variable. So that is what we need to think about. So to make this a little bit less abstract, let's just re-implement the default example from the anywidget documentation and a lot of their presentations. Okay, so what we're doing here is building a counter widget. So how it works is that it's a widget that keeps track of how many times we have clicked a button. So there's a count, and we also have an extra functionality, which is when the counters variable reaches the value 10, we trigger a confetti animation just to show how to use existing JavaScript libraries in our widget. So how this breaks down is that on the Python side, we need to have a count trait, which is the state, which is synchronized with the front end. So that's the current count. And on the JavaScript side, we need to render a button and make it so that every time we click it, it calls model set with the new value, and then model save changes. Okay, so our responsibility now is to implement the anywidget class. So we subclass what we get here from the library, and then we need to define the JavaScript source. So this is the anywidget module. We import some packages. Then we need to define the render function, which has model and the element that we want to insert our component into, basically. So in this case, we use this HTML library to construct a button which has an onClick function, so that when you click the button, it accesses the current value of the counter, and then it adds 1 and saves it. So it will update the state. And then you have a condition here. So once the count equals 10, it uses the confetti function from this library to trigger the animation that we talked about. And this is really what's displayed here. So you construct this HTML button, and then you append this to this DOM element. And then you have some update function here, which basically just sets the contents of the button. So it basically sets the current counter. And then we have also just included some CSS to make this more aesthetic. And here you can see we have the Python state, which is a count traitlet of type integer, which with the initial value of 0, and it's synchronized. So this is what happens. We construct the anywidget, our anywidget component, and then we just return it in the Marimo cell, and you can see it renders the HTML. And once we click it, you can see that the counter.count, the count attribute here is automatically updated. You have successfully tapped into the reactive execution model here. So as I click this, once it reaches 10, we'll get the confetti animation. Boom. We have also included some more information about the code that you can look into. Especially of interest is maybe how we're including external packages inline inside of Marimo here, which is very convenient if you want to prototype new widgets. So that was just a cute example, but now we will showcase how this plays out with security data and for our forensics data. All right, so let's now look into how to create an interactive process tree visualization. This is something we've done outside of this workshop, and we won't go into the details of it, but basically what we did was we found this dependency library from Square, and then we wanted to use this to render a process tree visualization, which was interactive. So it allowed us to drill down into process relationships. So we have a blog post here which goes into more depth about how we did this using anywidget and IBIS and so on, which we encourage you to read if you're interested. But at its core, what we're doing, we're wrapping this library, extending it slightly, and then creating an anywidget around it. So the idea here is to use this also with memory forensics data. So there's a PS3 plugin, which gives us, if you look at the output, it gives us the data in this format. So we have the processes, and then we have here the relationships. So these are like process IDs that keeps track of, okay, for process 2, the parent is process 0. So you have this parent relationships captures in the schema here. And we can just take a short look at the code. So we can look at the Python code. You can see here we have a process tree widget again, which inherits from anywidget, and then we're not defining the JavaScript inside of the Python file here. We're just referring to an external file. So you can see there's the JavaScript is in this location. And then we have basically the selected process ID. We have the list of events. We have a start date, an end date, and the option of showing a time filter. And then, basically the constructor here takes care of transforming the data to the correct format that the dependent tree library needs. So if we look here, you can see, let's see, where is it? For example, here's how volatility data is converted to the correct format by using a series of joins, basically, to get this tree representation. So, okay. When all is said is done, what we get back is this tree visualization with this optional time filter above, which you can say, okay, I just want to look at data from this range, this time range, and then you can drill down into this. So you can go into Explorer like this, and you can select this or that process, and then we have these. If you go back to the definition again, you have these threadlets here. So we have the selected process is available via the process ID field. So going back here, you can see here that the process ID is reflecting the currently selected node in the tree. Right, so we have the process tree widget, and now we can see how we can really use this. So for example, if we load another data set like the DLLs, we can create a filter based on the currently selected process from the tree. So as I said, let me look at the DLLs from Explorer. This will be automatically updated. Do like command.exe like this. You can see, these are the DLLs that particular process loaded. Taking this further, we could just create a really basic graph visualization. So here we're using a library called Sigma and another one called Graphology to basically create a graph representation of all the DLLs loaded by the process. So yeah, this is just you can read through the source if you want. Here I've split the JavaScript definition, the CSS, and the anywidget itself into 3 different cells. But what you get out here, you can see this is just one particular graph layout that shows you the DLLs loaded for command.exe process 304. So if I go back here, let's click on Explorer, for example, and I go back again, you can see I have this nice visualization which has automatically updated as I again highlighted something in a completely different widget. So everything is connected in a nice interactive fashion. So let's see if I can find something interesting here. This is just meant to be an example. It's not a suggestion that you should use this particular visualization to depict the DLLs, but yeah. So we can use the Marima notebook to easily prototype with new widgets, where we just include existing libraries inline and then we change stuff, or we can create Python packages that are standalone, like the process tree, which are more complicated. And then we can combine these different anywidgets to either create a interactive notebook, or we can use the app model and the grid layout like this to drag these output cells into the layout that we want, so we can deploy this again as a web application. So now we have this way of exploring the data, so we can jump between the processes like this. And remember, what happens in the Python side is that as I click this, we run the DLL filtering operation. We feed the results into this Graphology, Sigma, anywidget visualization again, that shows the DLLs for that particular process ID. And this is just a starting point. Here you can imagine, okay, so I could have tabs that let me switch between different views. We could have something that shows the handles, the files we have extracted, There's a lot of really custom stuff you can easily create here. Admittedly, this is just a little bit janky, but it was very easy to spin something up. And with that, you've made it to the end of the final notebook of the workshop. So great job going through all those different concepts. The purpose of this notebook was also to sort of try and tie together and spark new ideas. So, please share any feedback you have on social media or Discord. And also, if you build something or have any ideas, feel free to share that as well. I think as you start working with these tools, you will sort of generate so many different ideas, both when it comes to working with forensics data or just doing detection and response on, EDR data or log data in general. So yeah, can't wait to see what you all create, and we hope you've enjoyed the contents.